Welcome student. Today is your second class of operating system. In the previous class we have covered the introduction of operating system, how operating system actually works, their task, their functionality, and the different components of operating system and the layers of operating system we have covered. So today we will discuss about the evolution of operating system. So at the beginning, how operating system was and gradually how operating system evolved, that we will learn today. So it's a historical phase of modern operating system, from the initial phase to the modern operating system, how we have evolving the technology, that we will learn. So I'm Devashri Mitra, Assistant Professor of CSC Department, and these are my details. If you have any query regarding the class, you can drop me email. So I'm going to the content directly. So operating system, there are different types of operating system era. The early system was evolved during 1950. Then simple batch operating system came into the market in 1960. In 1917, multi-program batch system came. Then time sharing real-time operating system came in 1970. Next, in 1980, actually the first personal desktop computer came into the market. And next is the multiprocessor system. Then day by day, whenever the technology and the requirement of the technology has been increased, then network or distributed operating system came into the market. And then in 1990s, the web-based operating system, when Internet Explorer, different kind of internet browser are added to our operating system, then the new operating system, that is the web-based operating system era, has been started. So today we will start with time sharing operating system. So time sharing operating system, that means in batch multiprogramming, operating system does not support interaction with users. So time sharing operating system extends batch multiprogramming to handle multiple interactive jobs and multiple users simultaneously access the system through command entered at terminals. Processor's time is shared among multiple users. So in batch operating system, we have seen that there are some series of commands are written, and this series of commands are written into a file that is called the batch file, and through command prompt we have to execute the batch file, and the series of execution will be executed. Okay. So in case of time sharing operating system, we are adding some multi-programming features as well as some multiple user handling facility, or some multiple user handling facility has been provided with the multiprocessor or time sharing manner. So this is the time sharing architecture. In this case, just see, there are different processes are there. This is kernel. This is the different components of your system, that is the terminal, card, clock, disk, printer, tapes, network, and other computers also. Okay, and this is the user interface part. So these are the time sharing operating system. On the basis of all the resources will be utilized on the basis of time sharing manner. Next is why time sharing operating system is important. In time sharing operating system, the CPU switches job so frequently that user can interact with each job while it is running, creating interactive computing. So response time is very much low. That means we human being cannot understand the switching between from one process to another. Each user has at least one program or process execute in the memory. CPU scheduling supports several jobs ready to run at the same time. If processes don't fit in the memory, swapping moves from main memory to secondary memory by this manner. Next one is the virtual memory concept allows execution of processes not completely in the memory. Okay, so these are the features of time sharing operating system. Why did time sharing operating system work? So because of slow human reaction time, a typical user needs 2 seconds of processing time per minute. Then many users should be able to share the same system without noticeable delay in the computer reaction time. The user should not get good response time. It fits the economic basis of the mainframe computer installation. So next is the real-time operating system. So real-time operating systems are dedicated for some real life project, like where the timeline or the deadline, there is a time constraint is here. That means within a particular time some task has to be completed. So there is another feature, that is the correctness. That means the whatever the task or job will be done, that must be correct and the output must be correct. For a simple or the very tiny amount of error can affect the whole system. This is the features of real-time operating system. Next is there are two types of real-time operating system. One is called the hard real-time operating system. Another one is called the soft real-time operating system. In real-time operating system, that means the conflict with time sharing system not supported by general purpose operating system, often used to control industrial control, robotics, or secondary storage limited or absent. Data program is stored in short-term memory or read-only memory. So industrial control, robotics, this type of application are used for real-time operating system. In soft real-time operating system, where deadlines are important but not mandatory. So there are some limitations are few less. Okay. So this is also applicable for industrial control, robotics, and modern applications like video conferencing, virtual reality. This kind of system are implemented through soft real-time system. Next is the personal or desktop computer operating system. In this system, we all know there will be a monitor, there will be a display unit, there will be printer, there will be LAN card, there will be different components like technology developed for larger operating system. Okay. There is a sole use of computer, do not need to advance CPU utilization or protection features. So what are the operating system you can install for personal task? Windows, macOS, Unix, Linux, Ubuntu, etc. So these are the components of modern desktop computer system. We all know monitor, keyboard, USB, hard disk, CPU, memory, video controller, keyboard controller, USB controller, and hard disk controller. Okay. So in case of traditional personal computer system, these are used mainly for office environment and homework also. Nowadays students are using computers from their school life. There are two categories of computer systems: single instruction, single data, that is called the SISD, and the multiple instruction and multiple data. We have learned already in the computer architecture in our previous semester, SISD and MIMD. So now the multiprocessor system came into the market. That is, the more than one processor will be present in your computer. So it will increase the throughput, economy of scale, increase the reliability, and in this case there are the concept is called the tightly coupled and the lightly coupled memory. This concept came into in this scenario. So this is the multiprocessor architecture. In the first one is called the shared memory architecture, where in CPU 0, CPU 1, CPU 2, there are 3 processing unit. Each processing unit has its local register, cache, and a global memory. So this is the first diagram is called the global memory multiprocessor architecture. Next one is there is another global memory architecture. So this is the CPU 1 and CPU 0. There is also their local register, local cache, and this is the memory. Okay, so this is global memory architecture. Now this is the local memory architecture. Local memory architecture means each processing units will have their own local memory. That is the L1, L2, L3. This is the local memory or local cache will be there in each in design. So this is called the multi-core chips architecture or multi-threaded architecture also. So multi-programming versus multiprocessing. In the first diagram, it is according to the x-axis, time will increase, and there is 3 process 1, process 2, and the process 3. This is process 1, this is process 2, process 3. So now this is the timeline for process 1, this is the timeline for process 2, this is the timeline for process 3. So this is the multi-programming, but there is only one processor. But in this case, this is process 1, process 2, process 3. Whenever the multiprocessing are there, so process 1 will take less time as compared to the previous one. Process 2 will take less time as compared to the previous case. Process 3 will also take the less time as compared to the previous case. Okay, so this is the multiprocessing case in the below part. So there are 2 types of multiprocessor system: asymmetric multiprocessor and symmetric multiprocessor. So symmetric multiprocessor, each processor can perform the same function and share same main memory and IO facilities. The operating system schedule processes and threads across all the processor. Existence of multiple processor is transparent to the user. Incremental growth just add another CPU. Robustness is also an important measure over here. Next we will study the clustered system. Clustered system is like multiprocessor system. There will be multiple systems working together, and this is also called closely coupled system. Clustering allows us 2 or more systems to share external storage and balance CPU load. So what are the features of clustering system? Processors also have their own external memory. Communication takes place through high-speed channels, provides high availability. So these are the simple architecture of clustered computer system. So computer 1, computer 2, computer 3. This is computer 1, computer 2, computer 3. They all are interconnected through network, and this is a simple storage area or the clustered memory area which are shared between all these computers. Okay, and the load balancing, the utilization time, everything will be managed by the clustered computers. Okay, next one is this is the one diagram of clustered computer system. These are one computer which is called in master mode, and what are the computer are connected with the master mode? They are the slave mode or the computer node. They are called the slave node or the computer node. So they all are connected with local operating system of here, and this is the local operating system work. This node, master node, is called the remote network access, and this is the standard network, and all the computer are connected through a high-speed internet connectivity. Okay, so this is a simple architectural diagram of cluster computing system. So what are the features? Usually sharing storage via storage area network, or you can say it is SAN, storage area network. Provide a high availability service which survives failures. Asymmetric clustering has one machine in hot standby mode. Systematic clustering has multiple nodes running application monitoring each other. Some clusters are used for high performance computing where application must be written to use parallelization. Next is the network system. Distribute resources and computation among several physical processors. So these are loosely coupled system. Each processor has its own local memory. Processors communicate with one another through various communication lines. What are the advantages? Resource sharing, computation speed up, or load sharing, and the reliability. These are the three reasons for network system, distributed network system. So this is the computer network, and this is node 1, node 2, node 3, and this is node n. So they all are connected through network operating system. Okay. So requires networking infrastructure. LAN, WAN is also required. For point-to-point connectivity, P2P protocol is also required for if you are following the centralized server or the client server proceedings. Okay. Next is the LAN. This is the local area network. It is work on very small radius or the small area of locality. So speed is very limited. Broadcast is fast and cheap. So this is one example of LAN. So wide area network means the radius of the working area is little bit of high. Speed is also high. And this is the wide area network. Wide area network means the radius of the working area is also very high. This can be between two city or two town. Okay. So this is the one. And these are the component of one, that is the CP. This is called the communication processor. And this is the network host. This is one processor and hosting operating system. This is also one host. This is the hosting operating system. These two hosts are connected between this wide area network system, or it is called the communication subsystem. Okay. And this is the one architecture. So now the network attached storage, NAS. So this is the LAN or WAN. So what are the computer memory or network attached storage are connected with the system? They are called the NAS. So this is the NAS. This is the storage area network. So this is another example in the broad category. So this is the SAN. SAN is also connected with server, LAN, WAN. Okay. So this is the generic client server architecture. This is the, in the right hand, this is server. So these are the client workstation. They all are the client. So through LAN, WAN or internet they are connected. These are the diagram for client server computing. So a client server computing can also work as dumb terminal. Okay. Computer server provides the interface to client request a service, and file server provides the interface for clients to store and retrieve files. So this is the general structure of client server system. It is also network is also important features over here. Okay. And this is a single server. Single server is connected with multiple clients. Okay. So now the distributed system. In distributed system is a collection of loosely coupled processor and interconnected by a communication network. Processor variously called nodes, computer, machine or host. What are the reason for this using this distributed computing? That is the resource sharing, the first one. Next one is the computation speed up. Next one is the reliability, and the fourth one is the communication. That is the message passing is very important over here in the distributed system. So this is the diagram of distributed system. This is site A, this is site B, this is site C. This is your computer network. Site A is connected with site C. Site A is connected with site B. This is the communication channel. So by this manner distributed system are working. Okay. So next is the peer-to-peer. Peer-to-peer not distinguish client and server. Instead, all nodes are considered as peers. That means any computer can act as a client, any computer can act as a server. Okay, so as for example, voice over IP, VoIP, such as Skype, your WhatsApp call, any video conferencing call, whatever you are doing, okay, or any the voice message you are talking with, any voice message, all these things are peer-to-peer service. Anyone can be client, anyone can be server. So these are different distributed services are there: one-to-one, one-to-many, and many-to-many. These are the three architecture or the service way in peer-to-peer system. Okay, so next one is the networked operating system, or NOS. Each computer runs independently from other computer on the network, provides mainly the file sharing. Users are aware of multiplicity of machines. Access to the resource of various machines is done explicitly by remote logging into appropriate remote machines, remote desktop, transferring data from remote machines to local machines via file transfer protocol mechanism. Distributed operating system has also features like it gives the impression there is a single operating system controlling the network. Users not aware of multiplicity of machines. Network is mostly transparent. It's a powerful virtual machine. Data migration is also important features. Computation migration is also a good features. Process migration is also an important features over here. And the next one is the web-based system. Web-based system become very important. All the PCs nowadays, in all the PCs these features are available. More devices becoming network to allow web access. Nowadays our mobile, our any devices, tab, any devices, our laptop, they all are supporting web-based system. New category of devices manage web traffic among similar server, that is a load balancer, basis for grid or cloud computing. So what is grid computing? Collection of computer resources usually owned by multiple parties and multiple locations connected together. Such user can share access to their combined power, can easily span a wide area network, heterogeneous environment, crosses administrative geographic boundaries, support virtual organization. An example is EGEE, enable grid for eScience in Europe, Open Science Grid in USA. That means this kind of operating system mainly used for grid computing system. Assume there is a cluster of computer is available in India, and there will be a cluster of computer will be available in USA, and these two systems will be interacted through grid computing system. Okay. And the cloud computing system, collection of computer resources usually owned by a single entity connected together such that user can lease access to share of their combined power. What are the features are here important? Location independence, cost effectiveness, reliability. Okay, scalability, security, and readily consumable. Okay. So example of Amazon EC2, that is the Elastic Compute Cloud, Google App Engine, IBM Enterprise Data Center, MS Windows Azure, Sun Cloud Computing. These are the example of cloud computing system. Next is the handheld system. Handheld system is personal digital assistant, cellular telephones, just like our mobile, any personal devices like tab or any other devices which are where your internet is connected. So what are the issues over here? This is the limited memory, slow processor, small display screen, support for multimedia, image, video, etc. Next one is the mobile system. Okay, so Android, iOS, Google Android, everything is the example of mobile operating system. Okay, so mainly used for smartphone. It replaces the traditional laptop. More OS features are GPS enabled. Many new things are available over here. Okay, wireless facility, augmented reality, such new features are added over here. Okay, so example of mobile system are Apple iOS, Google Android. So this is one diagram, that is the migration of operating system concept and the features. So in the 1950, if you see, there is no software initially when mainframe came into the market. So in this case, in between 90 and 60, compilers, batch operating system, resident monitor, this program are invented. In 1960, time sharing operating system came into the market. In 1970, multi-user operating system, 80 to 90 distributed system. Okay, so what are the features are came into over here? So in this case, up to this the interactive case. Okay, so in the 1960 and 70s, the features is the multi-user. After 1970, that is the networked user. Before 1980, that is the Unix, multi-user, network, clustered, again Unix, multiprocessor, network, and this is the again Unix. So these are the features one by one, era wise we are getting over here. So this is the mainframe features. So mainframe features for 1950, 1960, 1970, 1980, 90, 2000. Mini computer features are these are the thing. Desktop features are these are the thing, and the handheld computers. Okay, and the last one is the interactive operating system. So these are the migration of operating system concept and the features. Okay. So these are some important questions for your exam. So go through all the questions and prepare the answers. And thank you. That's all for the day.